Hi all, this is the video tutorial for week 3, which is Circuit 2 in your ARDX kit. So let's go ahead and get started looking at what we're going to need. I'm sure we're going to need the Arduino itself. Got my kit. Let's start looking. So Circuit 2, it's very similar to Circuit 1, which we did last week, only we basically duplicate it. Looks like there's eight of them, so we have 8 LEDs and 8 resistors now. So kind of more complicated here, but same things we're going to use, just more versions of them. So we're using green LEDs, looks like this time, and 560 ohm resistors still. Okay, so let's start pulling out the parts. First I'll grab my sheet for this week. That's the one for last week. There's the one for this week. And remember, we're not stabbing them through with jumpers or headers to stick them on the breadboard itself. We're just using them as a reference. So you can do it a couple different ways. Looks like they're using the left side of the board, and I'll do that just to maintain conformity with them. And also you can see your LEDs. Once again, they're pointing out to you that the longer lead is what connects to the pin of the Arduino. And that is important. If you put the LED in backwards, it won't light up, because LED stands for light emitting diode, and a diode is an electrical device that only allows electricity to flow through it in one direction. So in this case, if we had it backwards, no electricity would be able to flow through the circuit. Another thing about an LED is that it has no resistance to electricity when it's correctly biased. That means when it's has the correct polarities. So if we went from pin 2 to the positive and then from the negative lead of the LED straight to ground, it would turn on for a minute, get really bright, and then burn out, because there's no current limiting built into most LEDs. So you have to use that resistor, or else you're going to burn up your LED or your Arduino, depending on which smokes first. So just keep that in mind. Unless you are using an LED with a resistor integrated into it, which is pretty unusual, make sure that you have a resistor in line with it. So I need to get out 8 green LEDs. So I'm just going to grab all my LEDs here. Okay, and then pull out the green ones. Okay, that's 2, 4, 6, 8. So I've got more than I need there. So I'll leave some of them up there in case I miscounted. Put the red and white one, or RGB one, back. Okay, and then I need a bunch of the 560 ohm resistors, which I've already got one bent from our previous tutorial. So I'll just set that off to the side. And then I'm going to need my wires. So I've got a bundle of wires. Okay, so let's go ahead and get started. Looking at it, I probably, to be neat and consistent and make sure I don't miss a wire or get things out of line, I'm going to put in all my LEDs first. And for every LED, I'm going to look and make sure that I'm putting the longer lead towards the far side of my Arduino, away from me. And I'm putting it kind of in the middle of, I'm putting mine in column C, because I can see that I'm going to need to put a wire in next to the positive lead, and I'm going to need to put a resistor in next to the negative lead. So let's go ahead and do that for my first one here. Okay, so the first one connects to pin 2. So I'm going to look for pin 2 and bring my wire that comes over to connect with the positive lead. So I'm going to put that into column E, row 1, so that it's connected to the top lead of my LED. Just to remember again, I know that's the positive one because its leg is longer. Okay, so I've got my connection from pin 2 to the positive leg of the LED. Then I'll take my 560 ohm resistor, go from the negative lead, which means I'm connecting into row 2, and I'm going to ground. So that's symbol here for ground. I'm going to be using the blue row for that. So I just bring my resistor over to the blue row. Make sure it gets stuck in good there. Okay, got that one. And I'm going to move my LED actually over to where it's right next to, so I'm moving my LED to row C so that I have a little bit more room for my resistor so I don't have to angle down quite as much so that it doesn't bump into my next LED and wire. Okay, so I'm going to leave a blank spot, so I'm not going to use anything in row 3, and then I'm going to do my next one, again, positive, long leg up on the board, so I'm skipping one row and then putting it in. Take another wire, and this time I'm coming to pin 3. So plug that one in, go to the top, take another 560 ohm resistor, bend it over, go from the negative lead, and take it to ground as well. Okay, so now I've got 2 of them done. Do another one. I'll speed this up hopefully when I'm posting this for you so you don't have to watch it quite as tediously. And it is to pin 4. I'm going to stop talking now because when I speed it up I don't want it to. Okay, so we've got all 8 LEDs with 8 resistors. They're all the correct resistor, green, blue, brown. Double checking things, looks like I should have wires into pins 2, 3, 4, 5, 6, 7, 8, 9. So look, starting at pin 2, going through 9, yep, got that. All the resistors should go to ground, so I make sure that they're all in the row next to the blue stripe, that I didn't accidentally get any into the red stripe. And that looks good for that. So the only things I need to do left now are make sure I get a connection from the Arduino to that ground bar. And if we look on our drawing, that's that would be, where's that wire? Down here, the 2.5 volt into ground. And it's fine to put the 2.5 volt, but as you can see, there's actually nothing connected to the plus 5 volts because we're not using anything that has continuous power. We're only using things that get power from the pins. So the only one we really need is ground. So I'm just going to put that one in, a black wire from anywhere on the ground bus, or the negative, over to, I'll put it to this ground here. Yeah, that one's right like that. Okay, so done with our wiring now. Double check all that before you start working on code or programming. So I'll switch over to look at the code now. Okay, so we finished wiring it, and you can see I plugged it in now, and I already had a program in there that was flashing one pin on my Arduino. So you can see one LED is blinking, but now we need to input the code for this week's. And you can see I've already written that all out in here. I'm not going to make you watch me type all that out. You can get to that code here in this week's tutorial 3. That code's here, and you can see this is basically what I've already typed in over here into my Arduino. So let's just walk through this. I didn't make you watch me type it, but I just want to walk through talking about some of the things that are important in this program. So starting out at the very top where we're defining integer protocol called an integer variable called LED pins. And now this week is the first time you've seen these square brackets, and you've already watched the tutorial, so you should have an idea what that means. But basically what that means is this is an array. So an array is a grouping of variables. So we can hold a bunch of related variables, in this case the number of the pins that each LED is connected to, in one array, and then we can cycle through them. So in this case, the LED pins the LEDs are connected to pins 2, 3, 4, 5, 6, 7, 8, and 9. And that's how we wired it. So that's great that those are like that. and just a reminder, if we were going to use one of these numbers somewhere down in our program, we would put the position where it is within the array inside the square bracket. So let's scroll down and look and see that. So right here is an example of that. Here we're doing pin mode. You should be familiar with pin mode from last week. Basically what this does is it sets that pin to be an output, because each of our digital pins we can set to be either an input or an output. And so it's saying LED pins, and in this case it uses another variable I, because this is part of a for loop, another new thing you learned this week. But that would reference, so from I equals 0 to I less than 8, so that's going to be 0, 1, 2, 3, 4, 5, 6, 7, because we know the numbers it's going to go up by are integers, because it's an integer variable. So for LED pins position 0, position 0, so if I is equal to 0, that's going to be pin number 2. When I equals 1, that is going to be pin number 3. So that's, again, the concept of an array there. So let's talk about this for loop. This is the first for loop you've worked with in one of your tutorials. So you've already watched a video about what a for loop is, but let's read through it together. So this basically says for, which means basically like for as long as, and then as long as what? For as long as this condition is true, that I is less than 8, do something. So basically everything inside this bracket here, its purpose is to determine how many times it's going to do whatever is between these curly braces here. So the first thing is the counter or the initialization. So we create another variable here called I. It's an integer, int_i, and it's set equal to 0. So we start this for loop with I equal to 0. And we continue the for loop as long as I is less than 8. So in this case, the next thing here is the condition that increments our variable I. And again, if you read through the links in the start of this tutorial, you should have seen that the plus plus sign means basically what it does. It says I equals I plus 1. So we'll try this in a minute, but this would behave identically typically if we put in here I equals I plus 1. It's just a shortcut way of saying that. So basically for 8 times, using I equals 0 through 7, do whatever happens inside these braces. And what happens is set a pin to be an output. So this is a quick way to quickly set all your output pins to be outputs instead of having 8 different lines with pin mode. Okay, moving down, we move into, and just remember that was under void setup. So this loop here is going to happen once when the Arduino first boots up. Once it's done that, it will go down into void loop. And void loop is the one required function that just runs over and over. And the very first thing that happens in loop is another function. This one isn't a predefined function. Again, you watched a video this week that introduced you to functions and subroutines. So this is a subroutine or function that we wrote instead of the default setup and loop ones. You can write subroutines that do whatever you want them to do. They just basically blocks of code that you want to reuse. So in this case, it's kind of a weird way to use it in that we're just using it once and using it over and over. But as your programs get more complicated, you'll likely have multiple function or subroutines that you would call. So now let's go scroll down a little bit further and talk about what's included in one after another loop. So we start out by defining this new function. We start by saying void. And again, hopefully this is a review from the videos you just watched. Void means that this subroutine is not going to return any data. The fact that these brackets or parentheses here are empty also means we're not passing this subroutine any data. We could have put variables in here that you would pass or send along to the subroutine when you called it in the program. You watched an example of that this week. Okay, inside this subroutine, the first thing is we define another integer. So this is a delay time equals 100 milliseconds. Remember, the units for delay are milliseconds. Okay, and we're setting that as a variable that then we can use down here where we have an actual command, but we'll get to that in a minute. So we have another for loop now. we're using I again for integer I equals 0, I less than or equal to 7. So again, this is another way of doing the exact same thing as we did in this for loop up here, right? This for loop, we did it as I less than 8. That got us from 0 to 7. This does the same thing, right? I equals 0. Now it's less than or equal to 7. In this case, since we're using integers, less than and equal to 7 or less than 8 is the same thing. That wouldn't be true if we were looking at another data type, maybe like a real data type where you could have a decimal. But when we're looking at integers, these I less than or equal to 7 and I less than 8 are the exact same mathematically. And then once again, we just add 1 each time we do it. So what happens during this for loop? So we look through what is between the braces, the curly braces. This is what happens. So the first thing that happens is we digital write LED pin and whatever pin I is right now. So I would be 0 the first time we go through. So that would be then if we look at LED pins position 0, that would be pin number 2. We turn it high. And then it turns on that LED. That's a comment telling what's happening there. And then it delays for however long we put in delay time. So for 100 milliseconds, it turns on the pin and then it goes back. And now, after doing that, I is now going to be equal to 1. So LED pin is equal to 3. So it turns on the pin 3 and then it waits 100 milliseconds, goes back and turns on pin 4, goes back, turns on pin 5. So it keeps looping through that, does this whole for loop here, does this 8 times, and that will turn on all the LEDs. Okay, then let's look down. The next thing that happens, we're still under one after another loop, right? This is still part of this program. And you can tell that if you're ever trying to figure out what is nested within each brace. Notice that when I put my cursor right next to that brace, it highlighted this brace down here. Same thing will happen, let's say I highlight this brace. You can see it highlighted this one. It's showing you the ones that it is interpreting as pairs. And that can be helpful if you accidentally get an extra brace in there or your program's behaving funnily. It's often because you have braces not in the correct order or an extra brace, etc. Okay. So we turn all the LEDs on and then we come down here and we do another for loop. This time we start with I equal to 7 and we're going to do it until I is greater than or equal to 0. So basically until I equals 0. And now instead of adding 1 to I each time, we're going to subtract 1. So basically this for loop counted from 0 up to 7. This one's going to count from 7 down to 0 in increments of 1. What do we do for those 7 program cycles? We write an LED pin low. So basically this chunk now turns the LEDs off. And it turns them off, waits a certain amount of time, then goes back around, turns off the next one. So it'll turn off the LED that is in LED pins position 7 first. So position 7 is 0, 1, 2, 3, 4, 5, 6, 7. So it turns off pin 9. Next time it turns off pin 8. Next time it turns off pin 7, etc. Okay, that's walking through what happens. So everything between this brace and this brace is my one after another loop. So coming back to the actual program that the Arduino runs, it automatically runs loop over and over again. So it's just going to keep doing this over and over. It'll turn all the LEDs on in order and then turn them all off. So let's go ahead and download that to our Arduino and see what happens. Okay, so if you look down here, it's behaving pretty much like we expected. It's running up from pin 1 to 9 and then reversing and going back down. Let's play around with our code a little bit then. I told you that this symbol is equal to I equals I plus 1. Let's just verify that. I equals I plus 1. That should behave just the same, so I'll download that to it. And it is. You can see it's behaving just the same. Same thing with this one down here. This is the same as I equals I minus 1. So let's download that and see if it behaves the same. Yep, it's behaving the same all right. Let's say instead of counting from bottom to top, I wanted it to count from top to bottom. And I don't want to rewire anything. I want to do that with code. Can you think of an easy way to do that? Well, there's a couple different ways we could do that. Let's do it one way first. What if we reverse the order of the pins up here in the array? So instead of 2, 3, 4, 5, 6, 7, 8, 9, what if we went 9, 8, 7, 6, 5, 4, 3, and go to 2. Did I get 8 of them there? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. So let's try downloading that and see what happens. And yeah, now since I swapped the order of the pins, I didn't change my code at all, but now I'm starting at the bottom one and going to the top and back down instead. Can you think of another way I could reverse it? What about if I reversed the order that the for loop occurs in? So let's say we have, I'm sorry, that's the one for setup. These for loops down here are the ones we're talking about right now. What if I switched the order of this for loop? So let me just copy that for loop and let me put that one right here. And copy this one. Put it right here. Get rid of that one. And okay, so check my braces now by selecting that one. Select this one. That's that for loop. That's the whole thing. That's that one. I think I got them in there right. So now to turn on the lights, it's going to start at 7 and go down to 0. To turn them off, it's going to start at 0 and go down to 7. So since we've already reversed the LED direction by changing the order of numbers up here, this should reverse it back to how it was before. So let's try uploading that. And yeah, you can see now it's counting down the other way again. So this is a good example of programming in Arduino. There's always multiple ways you can change something. You can, like there, I did it by reversing the order of the numbers in LED array or LED pins array, or I did it by reversing the for loops, whether they started at 7 and counted to 0 or started at 0 and count to 7. Just one more quick thing to point out how kind of useful this is. Let's say something terrible happened and you shorted out pin, which pin are we're using pin 9 for our last one. Let's say you shorted out pin 9 and burnt out the control on pin 9. So you couldn't use pin 9 over your Arduino anymore, but you wanted to have this same function again. So I'm going to do a wiring change, so I'm going to use pin 10 instead. So anytime I'm changing wiring, I unplug my Arduino from power. I'm going to move pin 9, the wire to pin 9, move it to pin 10. And now in code, all I have to do is change from 9 here to 10 here. And I'll plug it back in. It won't work right now because I haven't downloaded my new code yet. But let's go ahead and download now. Program using pin 10 instead of pin 9. And you can see now it's working again. So that's the flexible thing about using variables when you're assigning digital rights as opposed to actual pins. Let's think through, if you just used the skills you had last week before you knew about arrays and for loops and you wanted to do this same thing. Remember, when you turned on a light, that was an individual digital right to turn it on. Then you delayed for a period of time, and then you did a digital right to low to turn it back off. So it was 3 commands to turn an LED on or off. And here we have 8 LEDs, so you would have to have 24 commands just to get them all turned on. You'd have to have another, well, I guess we're turning them all on. So if you're just turning on, that only takes 2 commands, right? Turn it on and delay. So that would be 16 lines of code, and then another 16 to turn them back off. So that would be 32 lines of code that we have simplified into this one function, one after another loop, that really all it has is there's really 2 lines of code there, 2 lines of code there, and then 1 line for each for loop. So instead of 32 lines of code, we have 6 to do the same thing. So always, as you're programming things, try to think through, how can I make this simplest? How can I do the least writing? Because say you had hard-coded all those out with those 32 commands. If you hadn't used a variable array for your LED pins, if you changed 1 pin, you would have to rewrite a number of those commands. And more difficultly, you'd have to find the right lines where you address that pin specifically. So again, comments for everything will help you if you have to do that. But that's good. Let's say we wanted to speed it up. Before I do it for a minute, how would I speed up how quickly it ran up and down through those? Hopefully you're thinking, okay, the delay is what sets the time interval between when each LED turns on, and the amount of time is set by this variable delay time. So if I set this to 50 instead of 100 and upload that, it should go twice as fast now. Yep. Okay, I think that's enough for this tutorial. This has been a walkthrough guide for tutorial 3, which is CIRC-02. Hopefully this introduced you well to the concept of arrays. Up here is an array for LED pins. For loops, we got a couple for loops down here, and we have a subroutine or a function. That's where we write our own function that then we can call within the default functions, either setup or loop. Let's think about that. I guess that's a good thing to point out right here. What do you think will happen if I just copy this line, cut it out of the loop, and put it into the setup? Let's download that and see what happens. And hopefully you saw it did it just once. So if I reset my Arduino, it does it again just one time. Anything that is inside the void setup function only happens one time. Anything that's in the loop function happens over and over. There we go. Okay, I hope that helped you get ready for your project. So now go on and write the code for your project. The hardware is unchanged. You're just going to now make the lights blink on and off, not in sequence like this, but you're going to make all 8 of them turn on and off in certain patterns to represent your name. Last week we did it via last week we did it via Morse code, right? A single LED flashing off and on. This week we're going to do it in binary representing characters. So look for the project for more information about that.